Good day. Welcome back. Got another little project that came to my attention last weekend. We had the whole family over for a little gathering, and during the day we noticed that the house was getting pretty dang warm, and came to find out that the air conditioner stopped working. And I am by no means an expert on air conditioners, but I figured there's always YouTube out there, so I YouTubed a couple little videos, and they're not terribly complicated. There's usually just a couple things, one in particular that can go bad, and I figure, well, it's already broke, I can't break it anymore, so I'll tear it apart and see if what they're saying is actually not working inside there. It's a capacitor. It's a little power capacitor in there. There's actually a couple of them. So we'll tear this thing open, take a look at it, check it, see if it's bad, and if it is, we'll change it. So this air conditioner we put in when we built the house 20 years ago, and we've never done anything to it. It's never had any problems with it. So we've been lucky so far. So first thing, as with anything electrical, most air conditioners are going to have a service disconnect right next to it, which is what this is. And you're supposed to be able to pull this open. In there is there's several different ways. They could have little breakers. This one happens to have fuses, but to disconnect it, you pull this little breaker out and just set it up on top. But inside here, since this is so old, it's got a couple 60 amp fuses. And on YouTube, I never saw anybody with those type. Most of them had breakers. So we'll get into those a little bit later. But also in the house at the panel box, I threw the main breaker. So I pulled this out and I pulled the breaker off just to be safe. I don't want to depend on this. What they also say is this has still got power running to it. It's 24 volt power running to it. So even though we've killed all the power, there is still a 20 volt power source for the thermostat that is connected in here. So there is 24 volts in here. So if you touch something you're not supposed to, you can get a little tingle. It won't kill you, but it'll definitely make you tingle for sure. So we got to have to loosen this up. I'll probably just take it all the way off. And since the power is coming into this corner here, the condenser, I've got to pull this panel off, and that's where all the electronics should be. So let's pull it apart. So here's the electrical portion of the condensation unit. As you can tell, this thing's never been cleaned. That's something we'll do maybe when we're all done. I'll pull this thing apart and try to either blow it out, vacuum it out, or wash it out. But yeah, it could definitely use a cleaning. But what they normally say goes bad is that there's a capacitor, and they call that one, since this one's so old, most of them have dual run capacitors. This one's just a single capacitor, just because of the age of it. And that one there is the start capacitor. And what I'm seeing is some residue, like something has leaked. And I think it's leaked out of the start capacitor. So it may be bad also. But when you do this, you definitely want to take a picture of those wire connectors. See which wire goes to what connection on those. And something else I notice here, these are the two hot legs coming in, 110 and 110. This one here, it looks like it's gotten pretty hot. It's melted the insulation, got some corrosion on the wire. So I'm gonna probably cut that back, make a new connector, and reattach it in here. And just remember, you always want to throw the disconnect off, and just to be safe, might as well just turn the breaker off. You also have to discharge the power that's in these capacitors, because capacitors hold power. And when you pull these apart, you want to make sure you discharge them. You do that by crossing the leads with an insulated screwdriver or a piece of metal with insulation on it. Just get rid of the charge. Now this one here, the start capacitor, it's got a rheostat on it. And the rheostat's designed to get rid of that power, but we'll still cross those leads just to be safe. So we're going to pull this apart and test them, make sure they're bad, and then hopefully replace them. So since this isn't a true breaker, I'm going to go ahead and test these two fuses. You can't really tell looking at them whether they're good or bad. There's no indicator on it or anything, so I'm going to pull them out and I'll put a multimeter to them, check with an ohm meter, and just see if these are good. So power's off. Shouldn't kill myself too much there. So like I said, you want to take a picture of your connectors, because I'm going to disconnect everything here. And then I'll unscrew this strap and I'm going to pull this run capacitor out of here. It's got one screw right here. So what they say is, usually when these go bad, the top of it sort of explodes, almost like a pop can when you freeze it, and the top will bulge up. Well, this one does look bulged up to me. So we'll test it with the meter and see what it says. And I'll go ahead and pull this other one, the start capacitor, out too. And if you're going to be reordering all these, you just want to make sure you look at the volts, 330 volts, and make sure that number matches what you reorder. This is 135, 162 MFD. And then this one is a 27L322, but it's an 80, 440 volt. And when I was talking earlier about discharging the power in them, you do that just by crossing these leads, just by touching them with an insulated or some kind of a screwdriver with a rubber or plastic handle. That there just discharges the power. Same with this one, but with the rheostat, it should have taken it already, but we'll just make sure. So these should have no power coming out of them. So we'll go in the garage and try testing them. So I just got a little cheap Harbor Freight, again, multimeter. I've got it set on ohms. For the fuses, I'm going to test them just with an audible. So when you touch these two, when it's beeping, that means you've continued the loop of power. So if you were to test a fuse, if the fuse is good, it should buzz, just like that. If the fuse is good, it should buzz. So this fuse is good. And this fuse is bad. And that's one thing that I never did find a video on, showing how people would test that and whether or not it could be one of the reasons why it's not working. Because if you change these two and you don't check your fuses, I gotta believe that if you've got a dead fuse, it's not going to work very well. I'm going to go ahead and check the start capacitor, and it doesn't matter which connector you touch first. And all I'm doing is just seeing if we can get a charge out of this or power out of it. And I am getting power out of it. So to me, it's still working. And this is the one, you definitely see it, that it's bulged up on the top of that right there. and we'll see what the meter says. I got nothing. So I'd say that these are bad, and one of these are bad. So, through the magic of video, I have a new capacitor. I have a couple new fuses, and I did order a new start capacitor. Obviously, it looks quite different than the old one. It doesn't have the rheostat on it, but the numbers match. 135, 162, 135, 162, and it's 330 volts, and it's 330 volts alternating current. So even though it's a smaller size, we just have to modify the strap that attaches it. It doesn't have a rheostat, but that's not that big a deal. We just have to, short it out if you do play with this thing again. So I'm not going to change this yet. I'm going to put this back in and see if it runs with it, but I've got a replacement for it if I need it. But what I can do is verify what I have to make sure those are working. So these are the two new ones. These are from Home Depot. They're about 18 bucks for the pair. And of course, anytime you replace a fuse, you want to make sure you get the exact same one. The old one was an FRN R60. This is an FRN R60 amp fuse. So as you can tell, the new ones have an indicator to tell you if they're bad or good. If this one goes bad, this will be all black, and obviously it's good, so it's all white. The old ones, you have no idea if they're good or bad without testing them. So it'll be nice to put a couple new ones in there. So I'm going to go ahead and test these, see what they say. And both those are good. So the two new ones are good. I'm going to see what this start capacitor does. I'm going to kick it up to 20,000 on my ohm. Yeah, it's jumping up. Okay, now this guy, once again, doesn't matter which one you touch. And that's jumping too. I don't have a reading for the microfarads that these call for. All this is able to do is tell me if they've got power to them. And both these do. So they make fancy ones that actually can give you the reading of the 80 microfarads that this one is, and what the 135, 162 microfarads is on that one. But like I said, I'm just going to put the two fuses in that I know are good, and I'm going to put this run capacitor in. I'll turn the air conditioner on and I'm going to put this one into the old start capacitor and see if it's still working. So I'll go ahead and start with the fuses. Power is on. And you want to make sure you can see that window there. And like I said, you always want to take a picture of your connections. There's my connections on the start capacitor. So I'll follow that and connect that up. And like I said before, you always want to discharge the power on these. So even though I already did it, I did put some power to it with the multimeter. I'm going to discharge that power, and same thing with the run capacitor. I'm going to just discharge that. Like I said, I'm putting the old start capacitor in. And then I'll connect up the run capacitor. And from what I saw online, it didn't matter which one of these you connect. You know, like it really didn't matter because of the single run capacitor that they are. And for now, I'm going to leave that wire. I'm just going to fire it up to see if that did it. And hopefully we lucked out. I'm going to go ahead and reconnect this thing. These have a on position and they have an off position. So obviously I want the run position. And I've still got the breaker off too. And of course, like I said before, you always want it, you know, you can actually take this, invert it and push it back in and it'll be in the off position, but it's just better to pull the thing out and set it on top of the box. And I'll throw the breaker on, AC, that's on. And this thermostat is really hard to read. And we'll go outside and see if that thing is fired up. Lo and behold, YouTube strikes again, and it seemed to be that the run capacitor that was bad, and one of those fuses obviously is bad too, but it's running. So it's the next morning, and the air conditioner worked. It worked fine all night, and it's still running this morning. So today we'll go ahead and we'll clean it out, clean all those fins out, figure out how I want to do that. But also I wanted to change out that burnt connection there. So I'll shut it all down, make sure it's safe to touch, and then I'll change that out. So before I start messing with that wire right there, the red one, I've got a little voltage tester that I'm going to go ahead and just test to make sure. So this is a little volt alert. It's made by Fluke. It's a real good little tester. So I've got the service disconnect is still in the on position. The breaker's on, in the garage for the air conditioner. So you touch this lead here. This is one of the 110 leads coming from the box. So it's detecting power there. And here's the other one, the black one. And it's detecting power there. So those are hot. Those will, you touch those together, you're gonna probably end up killing yourself. So I'll go ahead and pull the service disconnect here. Test them again. And the red is dead. And the black is dead. And I'm also going to go in the garage and throw the breaker, but it's always a good idea to test those wires just to make sure they're dead. And like I said, there is still 24-volt power going in here for the thermostat wire, but at least that one won't kill you. Those two probably will. You know, I'm wondering if that one fuse that was blown was the fuse for this wire. It's funny that the fuse and then one of these wires are burnt so bad. And I don't even have I think that's 8 gauge. I think my wire stripper is only, it only goes up to 10 or down to 10. That looks a lot better. Just got a little replacement round one. That looks a lot better. What else we got? Cleanup. So I'm going to go ahead and start with my vacuum. Not sure if it'll work. If it doesn't, I can try my lawn or yard blower. I've got my air compressor. Also can, well, I'm probably going to have to anyways. I'm going to have to pull this fan cover off on the top just to get to the inside, because I think we want to, if we're going to blow it, we need to blow it from the inside out. And then I won't be able to get to any other sides, even to use the vacuum on the outside without pulling this thing off. They don't make it real user friendly for cleaning this thing. So we'll see. Let's try it. Compressed air. Yeah, I think that worked pretty good actually. So if I get the top off, not sure how I'm going to get inside of this, bending it back or something. But yeah, if you can get access to it, it actually blows it away pretty nice. I'll keep it going. We'll see how easy this thing comes off, if it even comes off. I'm sure there's got to be a wire attached to that fan somewhere. Several wires. They certainly don't make it very easy. 4 wires you need to disconnect to lift this fan out of here, because they didn't put a connection, or at least a plug that you just unplug here, which would have been nice, or at least not that I can see. I'll go get a flashlight and see what I find. Well, there is no plug connector in there, so I'm going to have to disconnect 4 wires. And like before, you want to just take a picture, but I've marked these. I've got brown, purple there, and I got black and red there. But yeah, up underneath there, that plug doesn't really come apart. So I'll pull wires. You know, I'm not certain this thing is even meant to be cleaned, because they got this rubber gasket around the top edge here. So I'll just take my compressed air and blow it from the inside out, and whatever I can get out is what it is, and put it back together. Because yeah, I don't see you getting to the outside of this without unscrewing the bottom and lifting the whole exterior off of it, and I don't really want to go there. Well, let's see how this works. I'm going to say that's good. So I had used up the memory, all the memory that my camera had. So I basically was just cleaning up the inside of the condenser there, and I put the panels back together and turned it back on to make sure it was working, and it is. So that pretty much finishes this little project. Fortunately it worked. Honestly, I'm a little surprised. It was just a capacitor and one fuse that was in the service disconnect. So yeah, it turned out well this time. I didn't break it anymore than it was already broke. So thanks for watching, and I'll see you on the next one.